So we're going to go over the hyperbola. We have two options for the hyperbola. So it can either open left and right, or it can open up and down. These top two are centered at 0, 0. And these bottom two are centered at HK. So I think it's better to memorize these rather than trying to memorize 4 of them. So if you know these two, you know the one for 0, 0. Let's go ahead and go over the two options that we have for the hyperbola. So let's go ahead and start with the center. So my center is going to be at HK. So let's call this one the center. And then my vertices are going to be aligned with that center either vertically or horizontally. If they're aligned horizontally, that means that my hyperbola is going to open left and right. Make sure that your vertices are also equal distance away from the center. So this distance here is equal to this distance here, and those distances is actually A. So again, these are my vertices. Vertex number 1, and this is vertex number 2. And this one is a center, which is at HK. So we also have foci. The foci are going to also be aligned with the vertices and with the center. So it's going to be to the right. So focus number 2 is going to be on the right of vertex number 2, and focus number 1 is going to be to the left of vertex number 1. So these foci are of equal distance away from the center. The distance away from the center is equal to C. So we said A was a distance from the center to the vertex, and we said that the distance from the center to the focus is equal to C. Alright, so how do we determine how wide my hyperbola is going to be? So in order to determine that, we're going to need something called a fundamental rectangle. So let's go ahead and draw a fundamental rectangle. This fundamental rectangle is going to touch the vertices, and it's going to be centered around those vertices also. So meaning the top of the rectangle has to be equal in terms of length as the bottom of the rectangle. So we're going to go ahead and draw a rectangle around touching the vertices. So in order to use this fundamental rectangle, what we're going to do is we're going to go diagonal. We're going to touch this corner to the center and then back to this corner and extend it. So this is going to help me draw the rest of the hyperbola. So we're going to go and extend it to the left and also to the right side. And you do the same thing for these opposite corners. It goes through the center and then it goes through as well. So again, this is going to help me determine the width of my hyperbola. And these should be straight lines, by the way. So let's go ahead and draw a sketch of my hyperbola by using the vertices and the asymptotes. So we're going to go ahead and open to the right, approaching the asymptote, making sure that this line does not go back in away from the asymptote, so it's approaching it. Same thing with the bottom half. Make sure that that part of the hyperbola is approaching the asymptote. And you do the same thing for the left side. So it should be approaching the asymptote, not getting away from it, and then approaching the asymptote on the bottom as well. So this is my hyperbola. So what are these points, the vertices and the foci? So focus number 2, we said the distance from the center to this focus is equal to C. So we're going C units away to the right side. That means that we're going to take the H and add a C. So focus number 2 is going to be H plus C and the same Y value, comma K. And for this one, for the first focus, we're going to the left side. So C units away from this center to this focus is C. So that means that the X value is going to be H minus C and the Y value is going to be K. The vertices, they're A units away from the center. So if it's A units away from the center, we're going A units to the right. That means this is going to become H plus A, and the Y value is going to still be K, and this one's going to be H minus A, and the Y value is going to be K, and that's because you're going a units away, but now to the left side. That's why you subtract an a. So what about the b? In the formula we have, for this one that opens left and right, we have a formula that looks like this. So x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So the difference between the hyperbola and the ellipse is that this one has a minus in between. And then the a squared is going to determine whether it opens left and right or if it opens up and down. A squared under the x tells me it opens left and right. A squared under the y's tells me that it opens up and down. So this one's under the x's, opens left and right. So what's that b right here? The b is the distance between the center and the top of the fundamental rectangle. So that means that this distance from here to here is equal to b. So that distance between the center and the top of the fundamental rectangle is b if it opens left and right. So the top of the fundamental rectangle, if it was opening up and down, then b would be the distance between the center and the right side of the fundamental rectangle. So if we wanted to find the equations for these asymptotes, we could use y minus y1 equals m times x minus x1, or you could go and memorize the equations that I gave you on this paper. So for this one, it's b over a times x minus h and then plus a k. But instead of memorizing, let's use what we know about lines. So we know that this line goes through the point hk. It has a rise of b and a run of whatever this distance from here to here is. So we know that that distance is a distance between the center and the vertex, which is equal to a. So if I go back and I use the distance of a is the run and the rise is b, then the equation is y minus y1, where y1 is a k, equals m, which is rise over run, which is a slope, so equals b over a, so rise is b, run is a, times x minus x1, where x1 is just equal to h. And then you can manipulate this so that it looks exactly like the ones that I gave you on the formula sheet. You can leave it like this if you wanted to on a test. So this is y equals b over a times x minus h. You add a k and you get exactly what we have again on the paper. Now if I wanted to find the equation of this line, this one's going down from left to right. So the only difference between this line and this one is that we're going to have a negative slope. So let's go ahead and try to use the rise over run for this one. So it's going to be y minus y1, so y minus, the y1 is equal to k, so y minus k equals m, which is a rise over run, rise is b, so this is equal to b over run, and run is now negative a, so you go to the left by a, which means that it's going to be a negative b over a, or b over negative a, which is the same thing, times x minus x1, and x minus x1 becomes x minus the h. Again, if you wanted to manipulate it just like we did on this one to solve for y, you get y equals negative b over a times x minus h plus a k. So that's the equation of the hyperbola that opens left and right. Now if you have a hyperbola that opens, or this is the equation of the asymptote for the hyperbola that opens left and right, and this is the other equation for the asymptote going up for the hyperbola that opens left and right. So the equation of the hyperbola itself is this one right here. Again, remember what we said. If the hyperbola opens left and right, this a squared is going to go under the x's. If it opens up and down, then that a squared is going to go under the y's. So the equation is going to look like this. Instead of x minus h squared being first, we're actually going to put the y's first. Y minus k squared over the a squared, and then minus x minus h squared over the b squared, and this is equal to 1. So that way the definition for a stays the same, the definition for c also stays the same, and the definition for b is going to be just a little bit different. Instead of going from the center to the top, we're going to go from the center to the right side. So let's go ahead and see what that looks like. So again, we start with the center, so that's HK. And then we have a vertex, and it's aligned vertically. So we have our vertex, this is vertex number 1, and then we have our vertex number 2, and we have our foci also. So focus number 1 is going to be here at the top, and focus number 2 is going to be here on the bottom. So in order to determine how wide we should be making these hyperbolas, and by the way, we know that it opens up and down because all of these are aligned vertically. So draw our fundamental rectangle through the vertex and vertex number 2, so vertex number 1 and 2, and then connect these. And then what we're going to do is we're going to go ahead and draw our asymptotes. So our asymptotes are going to go through the center and each of the corners of the box. And then same thing with the opposite sides. You're going to connect the center with the corners as well. So the distance between the center and the vertex is still equal to A. The distance between the center and the focus is still equal to C. The only one that changes is the distance between the center, or B, which is the distance between the center and now the right side of the fundamental rectangle. So this one is B. This should also be the same distance going to the left. So B, everything else is the same, but B is the distance from the center to the right of the fundamental rectangle, instead of going to the top. Alright, so let's go ahead and draw our points for the vertex, for the focus, and then we're going to draw our hyperbola too. So let's go ahead and start with the hyperbola. So this one opens up and down. And again, make sure that your hyperbola is not going inward, it's approaching the asymptotes and touching the vertices as well, of course. So my point for vertex number 1 is up by A units. That means that the y value is changing now. So the vertex number 1 is going to be H, comma, K plus the A. So the distance between the center and the vertex is A. And for this vertex, we're going down by A. So the x value is the same, H, and the y value is now K minus A, because you're going down A units. Now for the focus, for this one, we're going up C units now. So that means that the y value is changing, the x value stays the same, H, and the y value is now K plus a C, because we're going C units above the center. And now for this one, C units below the center, it's H, and K minus a C. So in order to find the equations of these asymptotes, what we're going to do is something very similar to what we did before. We're going to use the rise over the run. So the rise is going up, and then the run is going to the right. So the rise is the distance between the center and the vertex. So remember that this distance, let me draw it on this side. So this distance is equal to A. So the rise is equal to A, the run is equal to B. So then this becomes y minus y1 is K, is equal to M, which is rise, which is A, over the run, which is B, times x minus x1 is H. And then you can manipulate it just like we did before, y equals A over B times x minus H plus the K. So that's if you wanted to write it in that form. Again, you could just leave it in this form, the y minus y1 equals m times x minus x1 if you wanted to. Now for this one, the only difference is that this is going to be negative now. So the rise is A, and the run is now going to the left. So in order to go from this point to this point, you go up and then to the left. Up by A and to the left by B. So y minus y1 becomes y minus the K is equal to M, rise is A, over the run of B, and actually this one's negative because I'm going to the left, times x minus x1 is H. And then again, you can rewrite this if you wanted to. this is y equals negative a over b times x minus h plus a k. So that's my standard form, or this is my equation of the asymptote going down. This is the equation of the asymptote going up, and this is a standard form of a hyperbola that opens up and down.